Well, as I was waiting for people to vacate the room because they don't want to be bored too badly. I was given this great title, The Role of Standards in Clearing the Path for Technology Innovation, and in good form decided to speak about whatever the hell I wanted to speak about and just use the title. All right, so apparently we're not going to have too many laughs this morning, for which I apologize. I will talk about standards, but there's been a hell of a lot of talk about standards at the conference for the last 2.5 days. So I'm going to talk about a very specific form of information sharing, and that is sharing of threat and attack information, cyber threat and cyber attack information. So I don't see. Is that what moves the slides? Or do I say? Oh, here it is. Got it. I could just speak to that slide. So how many people have seen this document? I can't see it. Don't have my glasses on. It says something about information sharing and who should be doing it if in the federal government. And there's a specific part which can anybody read that? Actually, I didn't realize these would be so far away. But it basically says that there ought to be information sharing specifically for cyber threat and cyber attack. Between players that need to know about it in the federal government, and obviously that's going to be important to state and even local governments, and already has been in the cyber threat sharing world. There already are plenty of cyber threat sharing solutions out there. I'm sure most of you have heard of the DIB, the Defense Information Base, which has an approach to sharing cyber threats and cyber attacks. In the state where I live, Massachusetts, there is the Advanced Cybersecurity Center. How many people are familiar with the Advanced Cybersecurity Center, ACSC? We've got a few. Anybody not in Massachusetts familiar with it, besides Shemendra? Right, so this was set up by Mass Insight and MITRE and a bunch of mostly financial industry players in the Boston area to meet every Tuesday morning and share cyber threats and cyber attacks that they've seen over the last week, so that they can be prepared for what to expect over the next week, or what attacks they've missed over the last week. But I discovered very quickly that DIB and ACSC aren't talking to each other, and that's pretty much true across all of the different threat and attack information sharing situations that exist already in the United States and around the world. They're not talking to each other. One of the reasons they're not talking to each other is the legal reason. The layers of legal information that make it possible for example, ACSC financial industry and players to talk to each other. It's a big, thick stack of legal documents. But another one is they all use different approaches for the technical sharing of that information. They all use different protocols, they use different languages, and this is a pretty common problem in the software space. Almost every talk, I've only been at the conference this morning, unfortunately, but every talk I've listened to, somebody's talked about how difficult it is to share information because of the technology barriers that exist. Different solutions from different vendors, different solutions because of different demands from different users. So that's the great thing about standards. There's so many to choose from. That's right. Somebody be my rim shot, please. So you have, this is a partial list of the cyber threat and cyber attack information sharing standards that exist. The one that gets a lot of play today is the STIX taxi set of standards. That's basically information about threats and attacks, and then a protocol transport underneath it. But you also have, well, you can read the list as well as I can, CyBox and the common weaknesses enumeration and dozens of others. In fact, I believe the number from ISE is 54 different standards in this space. So clearly the right thing to do is throw them all away and replace them with one new standard that fixes all of the problems of the old ones, right? Everybody agrees with that, right? Some of you have already gone to sleep, I appreciate that. The real issue is not only is it a difficult problem with all these different standards, and every company in this space having its own solutions which are proprietary and which are not shared with anybody. The other problem is it's no longer going to be voluntary for long. Well, thank you. That way I can read it. If you read sections 8 to 10 of the President's executive order from February on cyber threat information sharing, you'll discover that these things are not going to be voluntary for long. So, what do we do? Well, let me talk about that one standard issue. I was trained as an engineer. I know some of you in the room are also trained as engineers. And engineers, when they see a problem that has multiple solutions already, they look at it and they say, we can do better. So here's a really simple example. Forget cyber threats and cyber attacks. How about electrical plugs? These are 5 of the 7 electrical plugs that account for something like 95% of the electrical outlets and plugs in the world. There's the one in the lower right-hand corner, which is the one intended by God to take over the entire universe, the 2 flat parallel blades. That would be, of course, the Japanese standard, also heavily used in the United States. There's the 2 round pegs. That's the most common European standard, but guess what? There are 3 different diameters for the round pegs. Any of you who have ever tried to plug in a German device in an Italian socket know that it won't work, even though they both use 2 round pegs. There are the various British variants, which are about this big, and they run 800 million volts through them, and no one understands why they're so big. I've asked Brits, you're expected to wire them yourself and know where the fuse goes and everything. And then there's, of course, the difference of what's coming through those plugs. So here in the United States, as God intended, 110 volts, 60 hertz. But in Japan, you have 100 volts and either 50 or 60 hertz, depending on whether you live in the north or the south, believe it or not. In most of the rest of the world, 220 volts, 50 hertz. Like many of you, I don't care about that anymore, even though I do, as Steve said, travel the world. My electrical equipment, a laptop and an electric razor, they can be plugged into anything from 24 volts DC to 250 volts AC. They don't care. By the way, anybody ever been to Bratislava, the capital of Slovakia? Yeah, don't plug anything in there. Just don't do it. I plugged my laptop in and it stopped working. Actually, it didn't stop working. It changed function. It changed from a laptop to a white smoke generator. Do you know the theory of white smoke? By the way, this white smoke theory of computing. If your kids ever ask you how do computers work, just tell them this: computers are full of white smoke, and if you ever let it out, they stop working. It's believable, right? No. So an engineer looks at this and says, 5, 6, 7 different standards. I could make the world a better place. I'm going to design the perfect plug that fits into the wall absolutely perfectly, that never slips out, that makes it impossible for little kids to put their fingers in the sockets, that senses how much power is required. It just solves every problem. And then replace the power outlets of the world with this fantastic power plug and power outlet. One little problem to overcome, and that would be the 3 or 4 billion power plugs and power outlets in the world. They're not going away. This is a really common standards problem that I call the N+1 problem, and that is the engineer looks at n different solutions, in this case 7, and says, I could do better, and instead of having 7 solutions, I'll have 1. In fact, what happens, as you all know, in fact, we all know this viscerally, but we never admit it, we go from 7 standards to 8. The problem gets just a little bit worse. That's why I call it the N+1 problem. And I'm afraid even the best meaning of solutions in the threat sharing space, for example, have this same problem. I'm sure that Sticks and Taxi will be fantastic and solve every known problem for sharing threats between commercial actors, universities, government institutions at the federal, state, and local level. But the other ones are not going to go away. Never. It'll never happen. They are legacy systems, and you know what a legacy system is. That's a system that never goes away. Right? By the way, my definition of a legacy system. A legacy system is a system which runs, that's all. You have to deliver it like that. But if you think about it, they don't go away. They don't get turned off. So if that's your problem, how do we solve that problem? That's in fact what OMG does. That's what we've been doing for 25 years, since I was 5 years old. I was a very early CTO. That was supposed to be funny too, but apparently fell flat on its face. The OMG has always focused on this problem of solving interoperability, portability, and reuse from the perspective of not ever being able to replace all of the things that came before, but rather connect the things that came before with the things that will come in the future, because you don't know what's coming in the future. So we're best known for a standard. We actually created the middleware space in the late 80s and early 90s with a standard called the Common Object Request Broker Architecture, or CORBA. By the way, those of you, anybody familiar with CORBA? Oh, not bad. And how many of you think Corba is dead? That's good. This is one maybe over there. You're all actually carrying running copies of Corba in your pockets or purses right now. There's one in every mobile phone, every telco switch, every robot, every banking system, most educational systems. It's quite amazing. And so what we learned from that is the point of a successful standard is to become invisible and bridge between other things. And that's a lot of what we've got to do in the threat sharing space as well. A little bit about OMG, I promise, just a slide and a half. We don't develop specifications, rather we adopt specifications that are proposed against requirements that we develop between our 500 or so members that are roughly half vendors and half users of information technology, and that includes governments as well. We require implementation of those specifications because standards that have no implementation aren't standards. They're just stacks of paper, or these days, bits on a disk. We want to actually create markets. For us, the standard is the starting point, not the finishing point. Around that standard, you have to create an ecosystem of commercial and open source implementations, of university training and education and certification and books and magazines and other kinds of articles and websites and blogs and so forth. That's how you create a real marketplace. So we're a member-controlled not-for-profit consortium. This is a list of some 50 of our members. It was carefully designed, this list, to make angry as many of you as possible by leaving your company and organizational names off the list. At least that's what people seem to think. Trust me, I vary the list every time. Those of you who are members, and I see many of you in the room, are carefully scanning the list so that you can be angry at me later in the day. I actually use this not to give you specific names of companies, because although there are obviously 50 companies there, 50 organizations there, but to point out that there are government organizations that participate, not only from the military and intelligence side, but also from civil side, for example, the National Archives, with whom we've worked for many years. There are big companies there, the Microsofts and AT&Ts of the world, and there are small companies there. So I bet you haven't heard of some of the smaller companies there. Every company, every organization gets a vote in the process because most of the innovations are actually coming from the smaller organizations. It's also worth noting that they are not all US organizations. In fact, only 44% of our members are based in North America, 35% in Europe, 10% in Japan, and the other, whatever that is, 12, 14% are the rest of the world. And I think the most interesting thing about this slide is not the flags at the bottom, but more importantly, that not every one of those companies and organizations is a vendor of information technology solutions. So you see actually some of our earlier speakers at the event. In the upper right-hand corner, PMISE is there. In fact, PMISE is there, but okay. These jokes are just going. Shemendra thinks it's funny, that's all I care. Yes, that's it. Other governments as well, so you see Canada up there. Canadian DND is a member, Japanese, Swedish, French, Australian government organizations as well. There are also companies that you may not think of as typical IT solutions providers. I like to point out, for example, Thales, Northrop Grumman, Lockheed Martin, Boeing, and so forth. Those are companies that make things that go zoom and things that go boom. See, now the Boeing people thought that was funny. I made that one up for the Boeing people, and they really liked it. The point is, those organizations are just as dependent on software as anybody else, as we all are today. They actually care about software standards. They care about threat information sharing. They care about banking solutions. They care about manufacturing solutions and integrated design solutions and so forth. One of the largest software development organizations in the world with 20,000 developers is Citigroup. Nobody ever guesses that, but banks are IT companies. It's not like they pass around, what is that old paper stuff called, money? They don't do that anymore. We also liaise with a large number of other standards organizations in specific vertical markets, in specific technology arenas, and in more generic spaces. For example, the single most important organization with which we liaise is the Open Geospatial Consortium. They're not on the slide there, so I had to mention it because Mark's sitting right there. But a large number of other organizations, we develop healthcare standards in tandem with HL7, one of the best-known brands in the healthcare space. Probably the single seriously most important organization is the ISO, the International Organization for Standards. That's what ISO stands for. Because we are what's called a publicly available specification or pass provider. So many of our standards become accredited standards. That's worth pointing out that we are not accredited. We don't use the ANSI rules for developing standards, but many of our standards do become international accredited standards through the pass process, which is true of many standards consortia. I don't want to dwell too much more on standards in general, but if you have questions and we have time at the end, I'd be happy to do that. I want to talk about some specific areas in which we develop standards. There are three key infrastructure areas which we're most known for. That would be, number one, the modeling space. So, been mentioned a couple of times over the last couple of days, the Unified Modeling Language, and Steve mentioned it in the introduction. And it is indeed a trademark, but it's not called UML-TM, it's called UML little t, little m there. Unified Modeling Language is used very heavily, not only by standards organizations, but according to Gartner and Forrester, by 71% of software development laboratories worldwide for modeling system software so that they actually build software that works and can be maintained and integrated later on. That actually is the first of many model-based standards that we have developed over the years, including languages for business processes, a language called the Business Process Modeling Notation, or BPMN, for modeling enterprise architectures, which was delivered first to the U.S. Department of Defense. UPDM is now the standard way for capturing DODAF models, but also is also used for MODAF models in the UK and NAF models in NATO. We also, as I mentioned, started out in the middleware space with the Corpus standard, but actually our best known middleware standard today is something called the Data Distribution Service. The DDS is used for high performance publish and subscribe integration of systems with transactional integrity and very high security in applications ranging from banking systems to energy trading systems to military to weapons integration systems. We also develop standards in the real-time and embedded space. But actually, the largest and fastest growing space in which OMG develops standards are in vertical markets, some 25 of them today. They range from financial services, where we have a solution for integrating different payment solutions between banks. Any of you who have been involved in payments are probably aware that there are literally 1,000 different payment solutions, even though they all do the same thing, take money from this account and put it in that account. They have different protocols, different APIs, different on-the-wire formats, and so forth. And they range from solutions at SWIFT and the Federal Reserve and regional payments processors with names like Shazam to more modern processors like Square and PayPal. We develop standards in the healthcare space, as I mentioned, with HL7, the Health Level 7 Standards Organization. In transportation and manufacturing, and probably most relevant for this audience, in civil and military government. We've been involved in communication standards, in logistics and shared operational picture standards for military organizations, and primarily with the United States National Archives and Records Administration, a standard for records management, which was delivered a couple of years ago now. We also manage a number of organizations that are not focused on standards, but instead on developing best practices, discovering case studies, success stories, failure stories, because you learn more from failure than success. And Steve mentioned one of those, the first that we created, the Service-Oriented Architecture Consortium. Actually, our currently most obvious one is the Cloud Council, our long-named Cloud Standards Customer Council, which brings together about 600 organizations, government agencies, as well as other cloud users, to share experiences in moving to cloud computing. That group has written, not the vendors, the end users in that group have written white papers on how to choose a cloud computing vendor, how to negotiate service level agreement with your cloud computing vendor, how to build secure cloud solutions, how to use cloud computing in healthcare, how to use cloud computing in retail banking. And membership in the Cloud Council, by the way, is, what's that price again? Yes, free. And all of the white papers are free as well. So I invite you to come take a look at that. Also, since I happen to be here, I'll mention that we are doing a public sector cloud workshop in March, the week of March 27th in Reston, not too far away. And if you'd like information, there's more on our website, or please come and see me after the talk. This is what happens when you let the marketing people touch your slides. They put other slides in. It's the same as the previous slide. I have no idea why they did that. One of the more interesting things that we're doing that is relevant to almost anyone who depends on software, especially who depends on secure software, is we manage a group called the Consortium for IT Software Quality, or CISQ, C-I-S-Q, which, starting from the MITRE DHS Common Weaknesses Enumeration, and then adding many more tests of software, is developing automated solutions for calculating the quality of software. So most of the software quality discussions that happen in the world today are around the process used to develop software, right? For example, CMMI. And CMMI has made a quantum difference in the way that software is developed. But unfortunately, it's not a metric on the software itself. It's a metric on the process used to develop the software. If you look at how Boeing accepts parts from its subcontractors, they don't just try to put in place, they do put in place a process called working together to ensure that their parts suppliers are using processes that are well integrated with Boeing's own processes. But they also test the parts when they come in the shop to make sure they're the right size, they're the right width, they're the right tensile strength, and so forth before they start putting them in airplanes. Because airplanes, well, Boeing calls them a million parts flying in close proximity. So you want to keep the proximity, in fact, really close, especially me, because I fly a lot. So we ought to be able to do the same thing for software, that is, test software before we accept it. And those acceptance tests should actually be automated, because if they're done by hand, they're not going to get done, and they're going to be very expensive. That's why they're not going to get done. So that group has actually pushed through the OMG a standard for automated function point counting, for counting the complexity and size of software in an automated way, so that you can actually just run it through a piece of software and get an answer. Think of that as the denominator of a defect rate. They're now finalizing a set of 82 software metrics that can be measured automatically, that is, by software. So you can tell the level of quality of the software itself, not the process used to develop the software. Very interesting. But I promised to talk about threat modeling, and I shall. In the threat modeling space, we have a brand new activity which is actually led from the commercial side. The leader of this effort is Gerald Buckelt, who's the Chief Information Security Officer at Demandware, the largest website nobody's ever heard of. Demandware is white-labeled and basically provides the websites and sales processes for the likes of Macy's. So if you've used Macy's, you've actually used Demandware. They face a fairly simple problem. They want to be able to take threat information from public sites, from state, local, and federal sites, but they also want to be able to take them from private companies that provide that information in proprietary formats, and be able to deal with not only your garden variety, but even the zero-day threats as quickly as possible. The problem is there are, what was the number? 54 different formats, and that doesn't count the proprietary formats for those threats. So if you're the CISO of a company like Demandware, which last year processed $67 billion worth of sales, and therefore you're a pretty likely attack victim, they're coming after you, how do you deal with that? And the solution, of course, is not to come up with yet another, and you knew I would say this, not to come up with yet another threat modeling format and try to get everybody to move to it, because that won't happen. You'll just end up with 55. But rather figure out what is the information model presented by those 54 different standards and by the proprietary vendors of information, threat modeling and attack modeling information, and then be able to ingest that information as quickly as possible. That requires expertise in the subject area. That requires being able to trace back information back to the source, and to be able to integrate that information very quickly. So that means you've got to integrate what exists, not replace what exists. Again, going back to the electrical plugs, you don't want to create the 8th different electrical plug. You want to create another solution. You don't want to create another solution. You want to create an information model that integrates. We call that a model-driven approach. It's underneath what we call our model-driven architecture, and we have languages for modeling how you do that. We have languages like the Unified Modeling Language, very well adopted in the industry. And I think very importantly, especially for this group, we have a just adopted standard called the NEAM UML. That's the National Information Exchange Model, Unified Modeling Language, which is a way to create NEAM IEPDs, which I know you've heard about for the last couple of days, so I won't get into it, using UML tools. And there are dozens, if not hundreds, of UML tools in the marketplace. That means we can finally bring together, using the UML to model the information and NEAM IEPDs, packets to actually physically share that information over networks, and be able to take information about threats and attacks from many different sources and use them in one place and integrate them intelligently. So that's the standards that's underway, the standard development that's underway. As I say, it's just started. You can think of it as a meta model for threat modeling. If you don't know what a meta model is, just remember that old important line from Will Rogers, I think it was, "I never met a model I didn't like." The meta model over there didn't laugh, so that's a problem. Bringing together commercial interests, bringing together mil aerospace interests, that's already happened, and government, which we've had tremendous support from information sharing environment, from ISE. Our mantra is don't create, integrate. Don't create another and worse situation by creating yet another standard, but integrate what exists. The goal is to be able to enable that integration that Gerald needs at Demandware, to enable not only conceptual integration, but to actual threat information and attack information that's coming from dozens of different sources, and to be able to react to it at wire speed. If you don't do that, you're going to get hit by every zero-day attack that comes across the wire, and that means we have to share that information and we have to share it at wire speed. That means we also have to have simplified creation of threat sharing and attack sharing systems, and the only way to do that is to have shared information models. I won't read this timeline in detail, but if you take a look at the slides later, you'll see we're talking about that this group is meeting every Monday by teleconference already. And we expect to have the final standard and an open source implementation, as a couple of different open source organizations are very interested in tracking this as it is created by the first quarter of 2015, so only a year away. If you're interested in this space, by all means, let me know. I'd be happy to get you involved in it. Moral of the story, I think you know what I'm going to say. It's important enough that we have to attack it, and we have to attack it with gusto. It's not just Demandware that cares about this. It's not just governments at federal, state, and local levels. It's commercial interests. It's personal interests. And the problem is in the cyberspace, in the cyber threat space, as you've already heard from several other speakers, the weakest link makes sure that everybody is attacked. And the only way out of that problem is to make sure that we have information shared at wire speed. We can't do it by creating yet another standard for integration. That won't happen. Don't create, integrate. And I'll hearken back to the original title and by saying that standards are the greatest force for innovation in the world today. The standards guys are all nodding, and everybody else is thinking, what the hell is he saying? I'll give you an example. For those of us who are old enough to remember the networks that existed before the internet, it was a mess. What happened before the internet was the ARPANET here in the United States, but there were several other networks in the United States, CSNet, UUNet, BitNet, a whole bunch of others. There was JNet in the UK, and there were dozens, if not hundreds, of other networks around the world. And if you wanted to send email, for example, I do remember from someone on the ARPANET to someone at BitNet, you had to know how to get which host was on both ARPANET and BitNet. Some of us remember this. And the route through the UUNet to get to the BitNet, and then the host that was on both UUNet and BitNet, and email addresses were, so I see some nodding heads around the room, all of whom are either missing hair as I am or have gray hair. There was even a book called The Matrix, you should look it up, which told you about all of the different networks and the different hosts on the network and the routes around those different networks to connect the systems together. That all got swept away in 1979 to 1980 with the invention of a fairly simple thing called the Transmission Communications Protocol, Internet Protocol, otherwise known as TCP/IP. That standard created enormous opportunities. That standard made it possible for us to have the web. I'm quite serious when I say standards are the greatest force for innovation in the world today. And that's the kind of innovation we're going to get in threat information sharing by having a standard information model for threats and attacks. Thank you very much. I think I'm only 2 minutes over.